Now let me say something about frames of reference. I've drawn this diagram and I'm doing all of the analysis in this entire presentation from the point of view or the frame of reference of the Earth, as if the Earth is not moving but rather is standing still. So in this diagram we see that in that frame of reference it's the galaxy that has a recessional velocity. Now the diagram and the analysis could be presented from a frame of reference of the galaxy or from any other frame of reference. But the choice of frame of reference will make no difference to the end result of the calculations. The choice of frame of reference is really determined by what makes it easier to conduct the calculations and to think through the process of what's occurring. Now I also want to make a point about the equation for deriving the Hubble constant from first principles. We've seen that the observed redshift on Earth is caused by two different factors. One is the Doppler redshift that results from the initial recessional velocity of the galaxy at time equals 0. The second factor is from the cosmological redshift that arises due to the stretching of space while light is in transit coming to the Earth. And we can model that in either of two ways. The first way works like this. This is the expected wavelength that the light would have if there was no redshift of any kind. Now, since there is a recessional velocity, we consider the Doppler redshift first. We calculate that, and then this wavelength 1 is the wavelength of the light when it leaves the galaxy after we've applied the Doppler redshift effect. Then while that light is in transit, it undergoes the cosmologic redshift, which further lengthens the wavelength from wavelength 1 to the wavelength that's observed. A second way of modeling what's happening is that this is the wavelength that we expect the galaxy, of the light that we expect the galaxy would emit if there was no redshift at all. And then first we consider the cosmological redshift of the redshift that happens during the time the light is in transit, which shifts the wavelength from this original wavelength to some other wavelength x. And then when the light comes to be observed on Earth, there's the Doppler redshift, which redshifts the light from wavelength x to the observed wavelength. Either one of those methods can be used. It's really a case of personal preference. Mathematically, it doesn't make any difference because, as we can see in the final formula, the order in which these operations are performed does not affect the result. I've chosen to use this approach because I found it conceptually easier. And here's where you can see that the order makes no difference. This is the final formula for calculating h from first principles. The final observed wavelength equals the original wavelength times the Doppler redshift component times the cosmologic redshift component, and the order of the multiplication obviously makes no difference which comes first?